Hello, my name is Jeff Fincher. I'm the product manager for HMP here at WireMasters, and I'm here today with Matt Gray and Renee Arnaud from Sumitomo. And we're going to be talking about their Sumitomo heat shrink tubing, termination sleeves, and their print systems today. Gentlemen, how are you doing?
Doing great. Thanks for having us, Jeff.
Appreciate you hosting us today.
All right, well, let's jump right in. For heat shrink tubing, I wanted to start off with that since it's one of the largest product lines that we carry and one of the largest for the industry that we support. So explain exactly what is heat shrink tubing and what's it used for?
So heat shrink tubing is tubing, as the name suggested, that will shrink to a predetermined shape after you apply heat. And the reason they do that is they want to have a tubing that they can fit over things that's maybe stretched to a certain dimension, and they'll fit over things and they can pull it over things, but then when they apply heat, will still shrink down and grab tight to the substrate.
So why would you choose heat shrink tubing over other types of protection like expandable sleeving?
Expandable sleeving is good for abrasion. That's the main purpose for expandable sleeving, but it's porous and open. A lot of times people don't want dust, dirt, water to get into their cable assembly. I think most of the, 90% of the applications for heat shrink tubing is to cover and bundle wire in like cable assemblies. So if you need that to be waterproof, you're going to want to use heat shrink tubing with adhesive parts at the end, and that makes it waterproof. Expandable sleeving will just make it abrasion resistant, keep it bundled, but it won't keep dust and dirt and water out.
So the sealing is the key benefit.
Yeah, one of them. Mechanically, it, again, bundles it, keeps things tight.
Yeah, okay. And I know that on the mil specs for heat shrink tubing, some of them will have different classes. What are some of those like classes, and what's the difference between them that sets them apart within a spec?
Well, there's one main spec for heat shrink tubing. Covers a bunch of material. So you have your base spec, which is the AS23053. And within that spec, there's 18 different slash sheets. And each slash sheet covers a different polymer that the tubing's made from. So you'll have your PTFEs, your Teflon tubings, you'll have polyolefin tubings, you'll have tubings that are made from neoprene. Each one of those have its own slash sheet. So slash 5 happens to be polyolefin. But within the slash sheet, there's 4 different classes in slash 5. So there's class 1 and there's class 3. They're very similar. They originally were supposed to be set up to be 2 different types of materials, but they end up overlapping. So if you pass class 3, you automatically pass class 1. So you'll see them dual listed most of the time. But class 2 happens to be clear because class 1 and class 3 are also flame retarded. Flame retardants tend to be black and dark in color, so you can't really make clear tubing that's flame retarded, so they made class 2. And then the mil spec, they just recently added class 4, which is a higher ratio version of the polyolefin. It's a 3-to-1 version. So you have slash sheets, classes, and then the next 2 digits would be a predetermined size chart within that class.
Okay, and speaking of ratios, so what's the difference on the different type of shrink ratios? I know there's a 2-to-1 and a 3-to-1 and I think a 4-to-1. What's the difference of them, and like what different applications would be used for? Like, does one shrink ratio mean a different application type, or what's the differences there?
So good question, Jeff. So as you said, 2-to-1, 3-to-1, 4-to-1, all different shrink ratios. Always comes down to the application. You know, could be you want a 3-to-1 tubing because it's a little more flexible, because at its base, each one of those tubings is extruded at the same size. The 2-to-1 would be, when it goes through the expansion process, it would be expanded to double its original size. And the 3-to-1 would be, triple the original size, and so on and so forth. So it's always going to recover to that same extruded state. And in the case of 4-to-1 shrink tubing, a lot of times you'll see it being used when you need to pull the tubing over a large connector, but it still needs to shrink down into a cable jacket that might be 1/4 of an inch. Or so really it has a lot to do with the application and how it's supposed to be used.
Right. Yeah. As you were explaining that, it sort of clicked for me. smaller connectors versus the real big, industrial ones, you would definitely need a larger sleeve that can slide over those. But then when it gets to the cable, the wire may be the same size on all of them.
And
Well, cable repairs, like one of the reasons they had those high ratios to begin with is the connector's already on there, but I just nicked my jacket. How do I fix it? I don't want to take the connector off. That's a lot of work. So if you can fit a piece of tubing over that connector and then it shrinks tight on your bundle and covers the little nick or slice that you have in your cable jacket, you've just repaired it without having to pull a connector off.
That makes sense. And so with the 23053 spec, the spec updated and we went from shelf life to dimensional life. So what does that change entail, and what's the difference between the old and new methods?
So basically, what they were trying to accomplish is, first of all, Naviair took over the mil spec. That's the change that happened in 2018. And they just wanted to set all of the restrictions and requirements for the heat shrink tubing. And in their past spec from years back, shelf life was always very restrictive. The manufacturers, like ourselves, wanted to have longer shelf lives than what the mil spec allowed. And that's because we knew our tubing would last longer than what they put in the spec. So they wanted to have some type of way that the customer, user, owner of the tubing could feel comfortable using the tubing once they went past the shelf life, which doesn't exist anymore. So now it's a dimensional life, which the manufacturers were able to give much longer time frames for. But now once you're past that dimensional life, a lot of the tubings are still good, and that spec allows you now to shrink it, gauge it, make sure the measurements hit what they're supposed to hit, and if they do, that tubing can still be used. So they didn't want to call it a shelf life if it could be used beyond its shelf life. So they call it dimensional life, and as long as it hits the dimensions, it's usable.
Right. So it's kind of like if it still measures to form, fit, function, it can still be used.
Absolutely.
And it's a very stable product, so as long as it's being stored properly and not in a really heat intensive environment, then it's not going to lose its characteristics. So that's why the decision to go away from the shelf life to dimensional life, made a lot of sense, and makes the lives easier of the manufacturer and those that have to have it in stock.
Yeah, definitely. So what are some examples of like products and applications that would use heat shrink tubing?
So I would say about 90 to 95% of our customers using heat shrinkable tubing, it's being used in and around a wire. So protecting that wire, sealing a component underneath a wire, moisture, blocking out water. Some of the more interesting applications that we have outside of wire and cable specific would be, we have some customers that cover gas hoses and flexible tubes with heat shrinkable tubing, sometimes for aesthetic purposes. So actually, if you think about a microphone and someone's at a podium giving a speech, there's a flexible hose that can reach down to talk to someone that's a different height.
Air Force pilot helmets with their boom for their microphone, that's covered with tubing most of the time.
Yep, so there's some applications where it's used for aesthetics and it really serves no purpose other than color and to hide what's underneath. And when it comes to wire and cable, protection is probably number one. But there are some different applications and some interesting things that come up.
Also, what are some interesting or uncommon uses that generally aren't thought of or generally aren't used that you guys have seen?
So I'd say for me the microphone one was a different one, and it's called gooseneck is what it is, the flexible hose. Mm-hmm. So a gas hose would be the same as the podium hose, and then the microphones that are used in Air Force helmets and pilot helmets. So to me that was one of the more interesting non-standard, if you will, applications I've worked on. But
yeah, I mean, we've had customers use it for shoelaces. If you ever have those clear plastic tips on shoelaces, that's not always heat shrink tubing, but they might want some unique colors. They can use that. I mean, so commercially, again, it's cosmetic in the colors, and Sumitomo has very rich, good colors compared to our competition.
Okay, so when we were little kids and our shoes got all messed up and the lacing got frayed, we should have come to you guys for heat shrink tubing and could have fixed our
parents
own,
a lot of money, I'm sure.
Just could have fixed our own shoelaces.
Yeah, and we've seen a few other interesting ones in recent years. We actually, out of our factory in Japan, we've developed a glow-in-the-dark tubing, which I'm told was developed for the fishing industry.
Huh.
And then, a few other interesting ones, not necessarily application, but interesting tubings. We started making one that has cayenne pepper in it for rodent protection. Prevent them from, mice chew through a lot of wires, and that can be a big problem. So especially if it's power or signal, and so we have a product that has cayenne pepper flakes in it.
Huh, that's interesting.
Very interesting. There's a lot of, you think of heat shrink tubing, and it's just, like I said, 90% of the time it's on a harness or a cable assembly, but there are some different unique uses for it.
That is cool. So one question we had actually from one of our team members here at WireMasters was the Sumitomo B2 and SM312 series. So both of these meet the same mil spec, but what's the difference between these two? So what would make one choose one versus the other?
So our B2 product falls under our Sumitomo product line. So, as we've discussed today, we have 3 different product lines at Sumitomo. It would be our solder termination sleeves, our Sumitube, which is just our standard heat shrinkable tubing for all the applications we just discussed. And then we have our, what we term identification products. So those would be used identifying wires, marker sleeves. So that's what we refer to as the ident product group. So B2 would fall under Sumitube, so just standard product for insulation. And then SM312 would fall under Sumimark product, which is in the ident family. And that's specifically meant to be printed on and used as a marker sleeve. So if you look at them, they meet the same mil spec, 23053 slant 5, class 1 and 3. But there are different product groups within Sumitomo. And again, the SM312 would be for marker sleeves, and the B2 would be just for standard insulation.
So termination sleeves is another product category that we're closely partnered with you guys on. I was hoping you could just kind of give us an idea of what termination sleeves are used for.
Matt mentioned STS, so for Sumitomo we call our solder termination sleeves the STS product line. And within that, the solder sleeves are a small shrinkable sleeve with a precise amount of solder within it, so they can do wire splicing. They can terminate a wire lead to a twisted shielded pair and grab the shield, bring that to a pin. Those are the most common applications. So people refer to it as a solder sleeve, termination sleeve, but just know they're kind of interchangeables.
That was kind of my next question, is what really is the difference if someone's referring to, even though they're interchangeable, but is there a difference between a termination sleeve, a solder sleeve, or I've also heard butt splice?
Butt splice would be a mechanical crimped splice. So we have that, that's a different mil spec. But that would be for splicing wire mechanically, and then our sleeving would insulate that, and it's a high altitude immersion resistant sleeve so that the aircraft can go to 40,000 feet and no moisture will gather within that, right? So it's a very high-end measurement butt splice, but there are cheaper versions of a butt splice, but it's really used to splice wire together. A termination sleeve and a solder sleeve, they can be interchangeable. They would be a soldering process of some sort. So you need to be careful. A solder sleeve to me was typically used in wire to grab the shield, as we mentioned before, or to splice wires together. A termination sleeve could be like a wire nut, or a sleeve or solder sleeve that would be used to put a wire to a pin, tab, or a post of a connector. So that's kind of terminating a wire. So that's why they call it a termination sleeve. But again, that's a common term. So a customer might be saying a termination sleeve, but really meaning a solder sleeve, what we call a solder sleeve.
And what are some applications that you'd use termination sleeves in?
For the most part, where you're going to find solder sleeves or termination sleeves being used is a process where repeatability is very important, a precise amount of solder. Our main market for that would be military and aerospace. So you want to be able to have a repeatable process where the alternative is hand soldering, and depending on who's on lunch break and who's doing the soldering, you could have different amounts of solder, resulting in a different outcome for the application. So repeatability, it's a standardized process too. 15 seconds under the heat gun, and so it's an easy process to have standardized. So military and aerospace, where those applications are so critical, that's where you find a lot of use for the solder sleeves.
Gotcha. So it makes it really easy to get the same result every time, regardless of who's handling it.
Right.
You don't have to have a 50-year master expert for every single time you're doing the soldering.
Exactly. You could pull someone in off the street, and as long as you tell them what to look for, then there's really no variability.
So that actually there's a couple of other reasons it's beneficial to use a solder sleeve, and that is total installed cost. So, people hand solder all the time, and they go, well, we hand solder because the solder sleeve's 30 cents. Well, they might hand solder, so they have the cost of the solder, they have the cost of the person of labor soldering it, then they have the cost of the tubing they use to cover that, and the labor they have now to shrink that tubing in place. Where a solder sleeve, it's all that all at once. It's the 15 seconds that Matt mentioned to install it, and it's all done at once, one cost, and it's a clear tubing so that your QC people can still inspect that solder joint, make sure it's good. If you hand solder and they put black tubing over it, you don't know if it's a cold solder joint, too much solder, it's uninspectable. So a lot of times people will have to do the solder joints, wait for QC to come inspect them, then they shrink the tubing over it. This allows you to do process much more refined, faster, and saves money in the long run.
Yeah, and I imagine if you're using that, then you'd have less chance of scrap or errors committed than.
Absolutely, and perfect segue, because if there is a mistake done with the solder sleeve, it's easy to tear off, put a new one on, and re-terminate. It's not that you have to cut wires. I mean, it's very easy to fix a bad solder joint.
So bringing things full circle back to the heat shrink world, the Sumimark print system for heat shrink markers. First off, when we say heat shrink markers, what are we referring to, and what are those used for?
So some people say heat shrink marker, some people call them a heat shrink label. They can mean very different things. To us, a heat shrink marker, a heat shrink label would be anything that's run on any one of our printers, whether it's the Sumimark or the Sumi tags. It can be in the continuous form, it can be in the formatted pre-cut form. So really anything that runs through our machine is what we'd consider a marker or a label.
And I think they're used in a more critical application where, again, the military, aerospace world tends to go to a heat shrink marker because it's a heat shrink piece of tubing marked on tightly on a cable, where wraparound labels, paper labels, whether they're metallized polyester, all are competitive forms of marker, might fall off and become FOD. So talk to anybody in aerospace, they do not want FOD anywhere on their plane. So it's a much more permanent marker. I always think it looks much more professional when you pick up a cable and say a nice heat shrink marker on it than it does if it has one of those little plastic wraparounds that kind of fall off and get stickiness all over yourself.
And FOD is foreign object debris, correct?
Yeah, the plane takes a right turn, you don't want this thing flying through the cockpit.
So what questions should a sales team or a sales member ask when the customer is looking for a printer system?
Yeah, because there's so many different options out there and so many different things that you can do with the marking systems, not only just in the selection of what printer is the best fit, but also what material is going to be the best fit for them. Most importantly, what is the application? Is it high temp aerospace application? Then that tells us what product we probably need to use, which would be higher temp. Is it a military ground vehicle? In which case you might want something a little more rugged and chemical resistance. So I'd say application's an important one. Volume would be very important because, again, we have 4 different printer options to cover, the low volume user all the way through the high volume printer runs all day long. So volume would be important. Temperature range kind of goes back to the application, but is it going to be high temp? Because we go up to 200 C on some of our products. Again, that comes with a little more cost. So if they don't need something that high temp, they can be at the standard 135C. So I'd say application, temperature range, shrink ratio, those are probably the most important questions you need to know.
Okay. And so what are the benefits of the Sumimark print systems, or their strengths, and how they differentiate themselves from their competitors?
So good question. Why don't we go ask Keith and have him.
Yeah, so Keith is our product manager. He's here today. He's gonna show you all the printers and all the different products we have that we can run through the printers.
Sounds good. Let's go take a look.
All right.
Let's do it.
All right, folks, now getting into the printer side of our business. We have multiple printer options, and we start out with our flagship product called the Sumimark 4 Plus. This is a proprietary system only to Sumitomo. You cannot get it anywhere else in the marketplace but through Sumitomo. I think of it more as a kind of the industrial strength, the high volume, robust, does the most, it's the most versatile of our printers. It can do 2-to-1, 3-to-1, 4-to-1 shrink ratios, dual wall products. It's primarily used for continuous spools of Sumimark product, which is rounded product, and we'll get into that in a minute. But so the flagship product, continuous, robust, most flexible printer. Next, we have what we call our SumiTag mid-size printer. It's an SSSX, but it's more for mid-size. It can do the continuous product, but it has to be flattened, or it can do also a formatted product, but they both have to be flattened. It's more of a mid-size, kind of like not the highest volume, but it can do a higher volume than the smallest printer. So this would be kind of like the next step down from the Sumimark. And keep in mind, only flattened tubing would work well in that. Then our third option here is what we call our SumiTag BBE5, which is kind of like a baby. The purpose of this guy is more for an entry level, just an economical starting point. And it too must be flattened tubing. It can do our SumiTag products for continuous or formatted, but it must be flattened. And now I will just go ahead and show each one of them printing, and showing the Sumimark. Now this is the continuous. You can see that it's round here, and it was perforated. So each one of these can easily just pull apart. And so you have perforated markers. There you go. So now for our mid-size printer. Now this is set up for a full cut. You can see just full cut markers, but it's flattened tubing. And lastly, the smaller economical size cut pieces, flattened tubing. So there's an example of all the three marking systems, and in operation, the benefits of each one. So just to summarize, once again, if you have a customer who's looking for the most versatile options in terms of shrink ratios, sizes, 1/16 to up to 2-inch width product, 2-to-1, 3-to-1, 4-to-1 shrink ratios, and even dual wall products, high industrial strength, lots of output, this is the printer that you should suggest. If they're looking for something that's more just a narrower range of products, 2-to-1, 3-to-1, sizes of probably, let's say 1/8 inch to 1 inch, this guy here is probably your better option. And then for customers who are just looking to maybe be very economical, looking for a very kind of like lower entry point in the cost, this is a printer you would want to go with.
So one of the product advantages of our Sumimark printer is that it's a continuous printer, prints on continuous material. So it takes standard round tubing, runs it through the printer, prints your markers. If you think of material cost, this is the least expensive option. is it's round, comes on big spools, runs through the printer. A lot of our competitors and some of the other printers require the tubing to be flat to be printed on. So basically, they have to take their round tubing, they need to run it through another manufacturing process to flatten it. So if you can imagine, you take the cost of this material, you have the adder to flatten it. Now this material is much more expensive than standard round material that would run through our Sumitomo machine. Then we have some competitors that only have formatted product. So the formatted product is our flattened material, again, run through another process of cutting it to 2-inch pieces and then mounting it on a carrier strip to make it a formatted product. That's adding even more cost to it. So the price per marker in this style printer would be a lot more expensive than running through our Sumitomo printer with continuous tubing that you cut to the length you need. So we should have an advantage of trying to replace our competitors that only have formatted product with our Sumitomo machine.